deep learning, artificial intelligence, machine learning, data science, like that. So many things are there. Just I'll give briefly. So when you go for deep learning, here we are morely focusing on the neural networks. So maybe CNN, convolution neural networks, or maybe deep convolution neural networks, or maybe RNN, recurrent neural networks. So like CNN is for images. So for images we can classify. RNN is for time series data. Suppose I want to predict coming next week what is the number of COVID cases. This type of time series data we are going to use RNN. So these things we are going to deal in the deep learning. But deep learning plus something else that is called machine learning. So in machine learning we have along with the deep learning. So deep learning plus something additional statistical models that is called machine learning. So there we have a Bayesian classifiers, various type of classifiers, or various type of predictive models. All those things are involving in machine learning. So that's why deep learning is subset of machine learning. In machine learning we are going to use so many statistical models, and based on that we are going to go for maybe prediction or maybe classification. These are the two objectives we are going to do in machine learning, either prediction or classification. Prediction means weather forecasting prediction, or maybe number of COVID cases by using regression analysis, by using decision tree, random forest, Bayesian classifier, support vector machine, etc. Or K means we are going to classify the data. So, or again, when it comes to the artificial intelligence, so deep learning is subset of machine learning is subset of artificial intelligence. So artificial intelligence also we are going to apply machine learning models, deep learning models. Along with we have some type of sensors related concepts also. So artificial intelligence objective is to make machine to think like human, like robots, all those things that comes under artificial intelligence. There we are applying machine learning models as well as deep learning models. Additionally, maybe some sensors, etc. concepts also we are going to use, maybe natural language processing, etc. also depends on the application. So that comes under artificial intelligence. So now coming to the final, data science. So artificial intelligence is subset of data science, machine learning is subset of data science, deep learning is subset of data science. Along with we have some data visualization tools and other tools like Tableau and Power BI or etc. So these are all comes under data science only. So that's why data science is a superset. These are all subsets of this one. So all are a little bit overlapping. I can't say exactly artificial intelligence subset of data science. Even artificial intelligence, some of the additional concepts also, but these are all overlapping. Moreover, when you take deep learning, machine learning, artificial intelligence, data lines, these are all overlapping. So that is the brief idea difference between deep learning, machine learning, artificial intelligence, and data science. So with this introduction, now I will move to the next concept that is called machine learning, because we are going to use most of the case studies by using machine learning, which is subset of data science. So I think it is clearly understood. Deep learning we are focusing only for neural networks, and machine learning we are focusing on statistical models. That means machine learning equal to deep learning plus statistical models. Artificial intelligence equal to machine learning plus deep learning plus some additional concepts, maybe natural language processing or maybe IoT related sensors concepts, etc. Data science means deep learning plus machine learning plus artificial intelligence plus some of the visualization tools like Tableau, etc., Power BI, etc. So these are all somewhere overlapping. So that's why we have a little bit confusion about these buzzwords. That's why I give a brief idea about all those things. Sorry, I'm checking. I thought whenever I'm getting sound, I thought maybe some message. This I explained. Now I will move to the next concept, machine learning. So I already said machine learning is the basic concept of extracting knowledge from the data. Based on that, we can make a model, hence we can go for prediction. So that's why, so here machine can use the data. So whatever, if you take human, so we can learn based on the experience, but machine can learn based on the data. Data is very, very important. Data is the fuel that drives the machine learning engine. Without data, nothing to do with machine learning, because machine learning is subset of data science that we discussed just now. So that's why data is very, very important. That's why without data set, we can't do anything with machine learning models. And what is the objective of machine learning models? It will go for prediction or classification. It may be weather forecasting, or maybe rainfall prediction, or maybe COVID cases prediction, etc. Or it may be classification, disease classification, or it may be other classification, mail classification, etc. we can do by using machine learning models. So basically, it is also a tool to extract the patterns from the data. And what is the difference between traditional programming and machine learning means? So when you come to the traditional programming, so let us assume I want to find sum of two numbers. So let us assume C equal to A plus B. So by using C++ or C language, so this is sum of two numbers program I have to write. So that's why data we have to give. A value is 5, let us assume B value is 3, so that you'll get output is 8. So this is a basic traditional programming. That means we have to write a program, set of instructions for the objective, that is sum of two numbers. After that we have to give input, so that you will get output, that is it. This is the basic traditional programming. So we are writing program, we are giving data as input, and finally we will get output. So but when you come to the machine learning, we are giving input as data as well as output, both we are giving input, and based on that it will make a program, or we can call it as a model. So after, by using that model, we can go for future prediction value. Now what does it mean? I think there's still not that much clarity. I will show one simple example. So you can see the COVID-19 data set. This is the synthetic data set, just for understanding. We have 9 cases, 9 COVID cases here, 9 patients data. So now this is nothing but input. So what is the input here? So symptoms of the patients, like shortness of breath, chest pain, fever, vomiting, etc. And we have each patient class also available. This is called output. We can call it as a class, or we can call it as a label. So that is called here output. So this is the input and this is the output. So same thing applicable for all the patients. Whatever patients, if we take here number of patients, all the patients having input, that is called symptoms of the patient, and output class also available. So this is the data available up to yesterday. Today, one suspected case of COVID-19 having following symptoms. These are the symptoms of new patient or active patient. Now what I have to do, based on the past data, I have to make a model, or we can call it as a program. So for that we have to give this input, these symptoms I have to give. That's why I said the objective of data science is to make a data into product. Now after making product, this I have to give symptoms to this model. Then it will predict automatically whether the person having COVID positive or negative. That means here the concept is input as well as our data as well as output is input to the system. So then it will make a model. So based on that we can predict the whether the person having COVID positive or negative based on the symptoms collected from the active patient or suspected case of COVID-19. So these are the symptoms I have collected: fever, chest pain, dry cough, etc. So that is the difference between traditional programming and machine learning. Now I think it's clear. So here we are getting output, here we are getting program, or we can call it as a model. When you have new data, we can give new data to the program, and based on that we can predict whether the person having COVID-19 or not. Or maybe we can predict country GDPA if we have data up to this year. Or maybe I can predict some number of deaths of COVID-19. Or I can predict weather forecasting like rainfall, etc. So based on that, whatever previous data available, based on that only we can predict the weather forecasting also. Like that, machine learning comes to the picture, and everywhere we require this one for future prediction, or maybe forecasting, or maybe classification. So I think you understood clearly the difference between machine learning and traditional programming. Now, when you come to the machine learning model, so we have a data. Data means understood the data set. And whenever if you want to go for machine learning model, we have to go for training. Let us assume 70% training or 80%. So depends on. So if we go for 70% training, so rest of the 30% I have to go for test data. So total 100% data we have. This I have to divide it into 70 plus 30 or 80 plus 20. First I have to train the model. After training model, it will produce a model. So it will, after training data, it will produce a model. Then this test data we have to give input to the model. That means a new model what we made for the training data. Then we have to evaluate the accuracy. If the accuracy is 95 or 98, etc., it is a good model. If accuracy is 40%, 50%, then we have to do further step. Maybe we have to change the model, or maybe we have to fine tune the parameters, and based on that we can go for new model. Hence we can go for better accuracy. Once if we reach the better accuracy, then we can deploy to the application. Maybe healthcare application, I have a more model, or I have a product of detecting COVID cases, or I have a product of detecting cancer disease. So that is the finally data is converted into product. That is the objective of data science. So then we can deploy to the application, maybe hospital, or it may be traffic prediction, or it may be weather rain forecasting center. So for that we can use these models. So this is the basic idea of machine learning model. So here we have classification problem. Binary, if I take, because in machine learning we have two things, one is classification, one is prediction. Both case studies we are going to discuss in today's session. So when you go for classification, we have to divide the given data into different classes or different categories. Like if we take a class, we have students, I have to make two categories like boys and girls. This is a binary classification. So whenever if I take a class, so I have a class, let us assume I have to divide two classes, one is group of boys, one is group of class. So group of goals, this is one type of classification. We can call it as a binary classification. Or maybe if we go for categorical classification, let us assume after results, I have to make a distinction student one class, maybe first class student one class, maybe second class students one class, and maybe third class students one class, maybe failed students one class. This is called categorical classification. So based on the percentages, I categorized the given student as distinction, first class, second class, like that. So these are all categorical values. That means the classification is categorical. So that's why depends on the application. It may be binary classification or categorical classification. If we take cancer disease prediction, I have to classify whether the person having COVID, cancer positive or negative, binary classification. Instead of that, I want to classify what type of cancer is having. It may be brain cancer or maybe lung cancer or kidney cancer or bone cancer. These are all categorical values. So this categorical values means a person, if I take, I have to check whether the person having cancer or not. If so, so we have to categorize which type of cancer is having. So that is called categorical values. So that's why we can go for either binary or categorical classification. It is applicable to both structured data as well as unstructured data. It may be tabular values or it may be image kind of data also we can apply by using convolution neural networks or maybe modified convolution or maybe deep convolution or maybe to be extended TensorFlow. Like that, so many things are there under deep learning. So now this is the basic idea of classification. When we come to the supervised learning, so here we are giving data that is called inputs or symptoms of the patient along with the class. C is nothing but class. So that means input as well as output we are giving to the model so that it will make U is nothing but model. So basically it is a function. D is nothing but set of records of patients, that is symptoms, and C is nothing but what is the type of disease like COVID positive, negative. Then it will make a model. Based on that we can predict the future value. That means here we have a student and teacher, that is called supervisor. So he is giving supervisor to the student. Based on that he will go for writing exam. When you come to the unsupervised, there is no teacher here. It's just like independent study. So there is no output. Just we are giving the data without any labels. So that means there is no output of the disease symptoms. Then it automatically we have to classify whether the person having disease positive or negative. So some applications unsupervised also giving accurate results, but most of the applications supervised learning will give more accurate results because of we have data samples along with supervision, that is called output or labels also available. But we are focusing more on supervised learning for all the use cases, what we are going to discuss in the further slides. So this is the basic idea. Supervised learning means X1, X2, these are the features or symptoms of the patient label. One is positive, 0 is negative. So here we can see input available and output also available. 1, 2, let us assume symptoms of the patient X1, X2 values, and label means COVID positive, 0 means negative. This is supervised model. So we have features X1, X2 along with output or label. But when you come to the unsupervised, this is unlabeled data. There is no out labeled here, labeled data. So we have only X1, X2 available. Symptoms of the patients I know, but I don't know what is the class, whether the person having COVID positive or negative, that we don't know. So based on that, I have to go for prediction. So it is a little bit risky task. That's why unsupervised we are not going to use here. What we are going to discuss in case studies, just we are applying supervised learning models. Semi-supervised means some labeled data, some unlabeled data. Maybe some data having labels, some patients having labels like COVID positive, negative, some patients not having any labels. That is called semi-supervised learning model. So these are the main thing. Of course, reinforcement model also available. So that is based on trial and error method. Their agent is involving. So whenever winning, then you will get reward, otherwise punishment. That is related to robotic applications, etc. So, but we are focusing on supervised learning model case studies only. Yeah, this I already said. Classification, we are going to classify the given data into true or false, binary or categorical values. Regression means we are going to find the continuous value, or it may be numeric values like predicting number of COVID cases or weather forecasting, etc. that we discussed already. So applications of machine learning. So it's almost similar to data science applications, what we discussed. So recommendation system we are going to discuss, and medical diagnosis we are going to discuss, and email spam detection case study we are going to discuss. So these are the case studies we are going to discuss in today's session. It's very quite interesting, and based on that, we can understand the significance of data science for our real world problems. So now I'll move to the case studies. So just I finished briefly about what is data science, and why data scientists having more value nowadays, and what are the applications of data science, and what are the things we have to learn if you want to become a good data scientist, like data analysis, machine learning, mathematics, and data wrangling, or maybe programming languages, like that we discussed, web scraping, like that we discussed so many things. And what is machine learning, what are the machine learning models, and what are the applications of machine learning, all those things we discussed briefly. So because I don't want to take much theory, because sometimes it leads to boring, so that's why I briefly explained the data science as well as machine learning also I've covered. Now we will move to the case studies of data science. Of course, machine learning also subset of data science, and also I gave difference between deep learning, machine learning, artificial intelligence, and data science. So with graphical representation, I explained briefly. Now we will move to the case studies. It's very interesting session, rest of the things, because every day we are being influenced with these case studies. So when you come to the case study, first I will explain recommendation system. So how the movies, or maybe products, or it may be doctors, or it may be music, or it may be books, or it may be dress, etc., recommending to the users or customers by using their data science models or machine learning models. And healthcare or medical industry case studies. So how the machine learning plays a vital role in healthcare or medical, by using a recommendation system, or it may be models, machine learning models, by using that how to do diagnosis. I will show case study on COVID-19, how to detect whether the patient having positive or negative based on the symptoms of the patient by using machine learning models. And cyber security, a case study I will explain, like how to classify the given mail is spam or not spam, because that comes under cyber terrorism. So because of most of the mails we are getting through that, phishing also possible, like click the details and enter your credit card details, then you will get prize, like that. So this type of things how to avoid. For that we will go for spam or not spam. And also intrusion detection system also we are going to do classification by using machine learning models. And forecasting, it may be weather forecasting, or it may be a COVID-19 prediction forecasting, etc. So by using machine learning models, how to do forecasting or maybe prediction. So these are the things we are going to focus for rest of the 50 minutes, so that you can understand exactly the significance of data science for our real world problems. So I think up to here is clear. Just we completed introduction of data science and machine learning with differences and also applications, all those things. Now we will move to the first one, recommendation system. So I already said every day we are getting recommendation of videos in YouTube, Netflix, or maybe Amazon website, etc. So what is exactly beyond this? So that means every day we are being influenced with this recommendation system. And one more thing, so 70% of the users are using recommended movies in the Netflix. According to the statistics, 70% of the clicks happening because of recommendation, and more than 35% of the revenue generated because of recommendation system in the Amazon website is e-commerce website. There we used to purchase mobiles, dresses, books, etc. So many things. So 35% or more than 35% revenue generated to the e-commerce website because of this recommendation. So 35% means it leads to $1 billion. So same thing for YouTube, etc. also. So these many application, I mean, advantages are having. Because of this, we are getting a huge revenue. That means owners of this. At the same time, as a customer, we are also getting huge advantages. So that means if you, without checking any video in the Amazon, from will get recommendation, or maybe YouTube will get recommendation, or if you suppose some mobile is released into the market, you will get automatically recommendation. So even as a customer or as a user, we are also satisfied with this recommendation, because without searching, we can find so many things. Or if you take downloading some of the apps, also will get recommendation. So Google Play Store automatically will download, even though some of the apps we don't know, but we will get recommendation. Based on that, we can download. Obviously, you are also happy, even though you don't know that about app, but you are downloading because of this recommendation. Like that, from our side as a customer user, we are also happy, and as well as the owners of e-commerce streaming services, they are also getting huge benefit because of recommendation. So both sides are happy. Now, recommendation basic definition is, because now we are in big data era, because it's very difficult to search data if we have a huge amount of data. That's where recommendation comes to the picture. Let us assume we have a set of movies. Let us assume these are all movies I am assuming, or it may be products, whatever it may be, you can assume. Let us assume I am assuming these are all movies available or in the Amazon Prime or Netflix, or maybe products are available in the e-commerce website. So this is my interest. Maybe I'm looking for one movie that is called a thriller movie, or maybe action kind of movie, or it may be a romantic movie. I'm looking for, this is my interest. What recommendation system will do? It will filter the movies which are not related to my interest, and it will recommend only movies which I'm showing interest. So I'm showing interest only romantic movies, then obviously these are the romantic movie which will recommend to you. So how it possible, all those things we'll discuss in detail. So this is the main recommendation system basic idea. So basically it is an information filtering system. Based on that, it will filter the items and hence recommend the suitable items to the customers or users, depends on their interest. But exactly what is happening beyond this, there is a question. The diagram is very simple, we can understand. It is a basically recommend a filtering system. It will recommend the items or products or movies to the customers based on their interest. But what is exactly happening beyond this? For that, we will see what are the types of recommendation system. So this recommendation system is useful in the streaming services like Netflix, YouTube, Amazon Prime, Disney Plus, even e-commerce websites. I already said, even healthcare medical industry also recommendation system are using. So how the doctors will recommend to the patients, or how the prescription, that means given to the other patients, how to recommend to the patient, new patients, or how to recommend the pharmacy, or how to recommend the drugs. All those things comes to the picture by using recommendation system. Even finance, agriculture, etc. also recommendation system. What type of crop we have to recommend to the farmers, all those things it will comes to the picture under recommendation system. Social media, we are getting friend request recommendation, even Twitter, YouTube, etc. I mean, sorry, Facebook, etc. We are getting request. How this is because of this recommendation. And even e-government, tourism is what type of hotel we require, based on that it will recommend automatically. And library textbooks, it will recommend. Hotels, what type of hotels, it will recommend automatically. Like that, huge number of applications we have under recommendation system. There we are applying machine learning models. Based on that, the owners of these e-commerce streaming services are huge benefit. Even as a customer or user, we are also happy and we are also getting benefit. Now we have types of recommendation: popular based, content based, collaborative filtering, or maybe content based filtering. When you come to the popularity based or popular based, so it will recommend the movies automatically based on the trending. For example, let us assume, so maybe yesterday or maybe today released a triple R trailer. So whenever this triple R is trailer released, so this is the most number one trending trailer in the India, then automatically will get recommendation. So that is the popularity based recommendation or popular based recommendation. So or maybe one mobile released in the e-commerce website that is more popular and most of the customers are waiting, maybe Apple latest version, let us assume, then automatically it will recommend to the customers. So that is called popularity based recommendation system. And content based and collaborative based filtering I'll explain in detail. So always based on the trending or popular among all the users, that will recommend automatically in the popularity based recommendation system. But when you come to the collaborative filtering, so I will show one examples also for this. What is collaborative filtering? And so based on that, how the items or products are recommending to the customers or users, that we will discuss in detail. So let us assume we have two users, A and B. So both are watching the movies. Let us assume Crack and KGF. And this indicates that there is a similarity between these two users, because both watched the movies, these two. So there is a similarity between these two users. So now what happens, whenever she watched the movie Bahubali, then automatically this will recommend to this user. So that is the collaborative filtering. That means it will look for similarity between users. Based on that, it will recommend automatically movie, or it may be product, or it may be book, or it may be music, etc. So that means, so A and B having more similarity because both watched the movies KGF and Crack, and both are action oriented. Whenever Bahubali watched by her, it will recommend to him B. Whether he is going to watch or not, that is left to him. But the recommendation system objective is to recommend Bahubali to B user. Why? Means both are having more similarity, that's why. Or suppose if B watched the movie, let us assume some movie, let us assume latest movie, Akanda, let us assume Telugu click. So let us assume So suppose he watched the movie, let us assume Akanda, then automatically this movie will recommend to user A because both are having similarity. So that is the collaborative filtering algorithm. So that means collaborative filtering algorithm looks for similarity between users, and based on that it will recommend automatically to the other users. Now we are going to focus on this collaborative filtering algorithm for healthcare application or movie recommendation also. Now, when you come to the content-based filtering algorithm, the basic idea of content-based filtering algorithm is the past activity. For example, I have Amazon account, Amazon e-commerce account. So I use it to purchase only Samsung mobiles. Last 1 year, my past activity is 5 Samsung mobiles I bought. So now whenever new Samsung mobile released into the market, automatically I'll get recommendation. My past activity is Samsung mobiles. I used to purchase only Samsung mobiles. So that's why whenever new Samsung mobile or new Samsung model released in the market, automatically it will recommend to me. So that is the content based filtering. So that means here basically these filtering algorithms look for the past activity of the users. Based on that, it will recommend automatically. Suppose let us assume one girl used it to order only Fair and Lovely creams last 2-3 years. Then obviously whenever new cream comes to the picture, then automatically that cream will recommend to her. So that is also content based filtering. Suppose if you take this movie recommendation, so he watched the movies, movie 1, movie 2. Let us assume user A. So he watched the movies, movie 1, movie 2. Both are comedy movies, or comedy genre. We can call it as a genre. So, or we can call it as a comedy category, simple word. So both are comedy categories. So maybe he watched this in Amazon Prime or maybe Sun Next. That is also one of the OTT platform. In Sun Next, he watched movie 1, movie 2. Now what happens today? 3 movies are released. One is movie 3. Sorry. One is movie 3, one is movie 4, one is movie 5. These 3 movies are released in Sun Next. I am taking Sun Next OTT platform, or maybe Amazon Prime OTT, or maybe the Sun Netflix, whatever it may be. So now what happened when you take fast activity of the user? He liked only comedy movies. That is the indication. So based on that, the recommendation system will recommend comedy movie to him. Why means, so his past activity shows that only he used to watch comedy movies. That indicates that, so maybe he likes more comedy movies. Because of that reason, whenever comedy movie released in the OTT platform, then automatically that comedy movie will recommend to him automatically. So that is called content based. Based on the past activity of the user, it will recommend automatically. It may be movie, or it may be product, or it may be music, or it may be textbook. So what textbook meaning is, suppose I used to buy only Python textbook last 1 year in Amazon website, then whenever new Python textbook is published, then automatically I will get recommendation. This XYZ author Python textbook is published in the, or maybe released in the market. So it will recommend to you. Whether I'm going to buy or not, that is left to me. But the recommendation engine will recommend these items automatically to the users based on the fast activity. Now I think it's clear what is recommendation system. Now we will see one small case study. You can understand how it will recommend, because I explained the difference content based, collaborative. Now how we are going to apply to the one movie example. I will take movie data set. So if you are looking for movie data set, you can go to this website, Group Lens. This is the website. There we can find the data set of movies. So I will show the screenshot here. You can see this is the screenshot. So user ID, or we can call it as a movie, username, whatever it may be, and movie ID or movie name, rating given by the user. So maybe user 1 given 4 rating to movie ID 3740, like that. So timestamp means time when they given the rating. That is not required for our further steps. We required only what is the movie, what is the customer, and who is the customer, and what is the rating given by customer. These are the things we require. So here we require some pre-processing step that is called utility matrix or user item matrix. So we have user and items. So we have to write users are rows and columns are nothing but items. And we have 5 users if we take this data set, and we have 4 items. And the rating given by user 1 to item 1, you can see here in the first row, the rating given by user, the rating given by user 1 to item 1 is 5, and user 2 to item 1, item 2, item 3, item 4 is like this available. So all the ratings are available here. That is called utility matrix. First we have to find the utility matrix. Then our objective is to find the missing values. So here we know. So this is missing. The some of the matrix elements are missing. Our objective is to find this missing values. That is called rating prediction. Once if we done rating prediction, then we can decide whether we are going to recommend items to the users or not, whether we are going to recommend movies to the users or not. So that is the objective. The objective of recommendation system is to identify the missing values, that is missing numbers, that means missing ratings. After that, based on the missing ratings, we are going to decide whether which movie or which item going to recommend the users or not. That recommendation engine will take care automatically. So these items we are going to recommend, or these the movies are going to recommend. So that is the objective of recommendation system. So I will show one small example. So here one example I will show correlation coefficient formula by using that how to do recommendation. I think yeah, everyone studied this formula, correlation coefficient, to measure the correlation between two variables in statistics, maybe engineering or maybe PUC. So are intermediate. So here x comma y are two users. So x and y are random variables in statistics. I'm taking two users, user 1 and user 2. So we have to look for similarity, because I'm looking for collaborative filtering. In collaborative filtering, we are looking for similarity between users. So that's why we are using correlation coefficient. So numerator we have to find, that is called covariance, summation xi minus x bar into yi minus y bar. So this is a standard deviation of user 1. This is a standard deviation of user 2. So that means basically we are looking for similarity between two users or correlation between two users. Whenever there is a more similarity, we will do recommendation. Otherwise, we are not going to do recommendation. That I am going to explain in the further slide. So same formula I'm going to convert for recommendation. Similarity between A comma B. A is one user, B is one user. So RAP means rating of user A for item P. RBP means rating of user B for item P. Because we are looking for collaborative filtering, there we are considering the rating. So based on that, we have to calculate correlation coefficient between two users. Based on that, we will see how we are going to recommend. So here, this is the data set I am taking. So we have 5 items and 4 users. So whenever if I take this data set, and this rating is missing here. So that means our aim is to find this rating, and hence we will decide which item, whether item 5 is going to recommend to Daivik or not. So once again, this is the data set I have. All the ratings are available, all the users ratings are available, but Daivik to item 5 rating is missing. So our aim is to find this rating, followed by whether we are going to recommend item 5 to Daivik or not. Maybe slippers we have, whether we are going to recommend the slippers to Daivik or not. So for that, what we have to do is we have to find the correlation coefficient between each user. So I already gave this formula. We have to find covariance of numerator, that is called numerator, and standard deviation. Everyone knows how to do standard deviation correlation. So because of time factor, I'm directly giving the values here. Otherwise, because I said already, recommendation system only I used to take 3 hours. So that much time we don't have. So directly I'm calculating. So Daivik to Gopi, the correlation coefficient or maybe similarity is 0.85, 85%. And Daivik to Sachin, so 0.7, 70%. And Daivik to Vishnu, so minus 0.07, that means 0%. So why I'm calculating Daivik to other users similarity means, so the rating is missing for Daivik to item 5. Whenever rating, if we calculate, that means correlation coefficient, if we calculate, based on that I can decide which user is very close to Daivik or which user is very similar to Daivik. Based on that I can go for rating prediction. Now we calculated just similarity between Daivik and Gopi, similarity between Daivik and Sachin, similarity between Daivik and Vishnu. You can observe that similarity between Daivik and Gopi is 85%. Rest of the values are little less than this one. So hence there is a huge similarity between Daivik and Gopi. So that is the thing. Now you can see right side. So Daivik and Gopi similarity is 85%. Daivik and Sachin 70%. Daivik and Vishnu 0%. Minus means 0%. Now what happens? We have a high similarity between Daivik and Gopi. I already said about collaborative filtering. There we are looking for similarity between users. Based on that, the movies will recommend automatically. Now whenever if we take similarity between Daivik and Gopi is very high, whatever rating given by Gopi to item 5. So here rating is 3. So same rating we are going to copy paste here because both are similar. So we can predict the rating for Daivik to item 5 is 3. So hence rating prediction done. So how to find rating prediction? We have to look for highest similarity between Daivik to other user, and Daivik and Gopi similarity is high when compared to the other users. Hence the rating prediction is nothing but 3 here. Whatever rating given by Gopi to item 5, that you can copy paste here. So the rating prediction is 3. Now the question is whether we are going to recommend item 5 to Daivik or not. Now according to my threshold value or maybe my program, so my minimum recommendation for 4 rating, otherwise I'm not going to recommend. rating should be minimum 4 or maybe greater than or equal to 4. I can recommend items, otherwise I am not going to recommend items. But what is the rating prediction by using similarity index 3? So hence I'm not going to recommend item 5 to Divik. That means machine learning or maybe recommendation system not going to recommend item 5 to Divik. Suppose if the rating is 4, let us assume instead of 3, let us assume here 4 and here also you'll get 4, copy paste, then item 5 is recommended to Divik. So hence what's the conclusion? So item 5 is not recommended to Divik. So because I am assuming minimum threshold value is 4. Whenever rating is 4 or maybe more than 4, I'm going to, because I'm taking rating scale is 1 to 5. 1 to 5 is 1, 2, 3, 4 is poor average, I'm assuming. So that means 3 means I'm not going to recommend to Divik. That means item 5 is not going to recommend to Divik. So this is a simple classical example. So how the recommendation system works. So that means based on the similarity between users, it will calculate the rating prediction, and hence if the rating prediction value is 4 or more than 4 from 1 to 5 scale, then automatically it will recommend, otherwise it won't recommend. So here I have one small quiz for the participants. Now we can, I think this is understood. What is the basic idea of this recommendation system under collaborative filtering? It will look for similarity between users. Based on the similarity, we have to go for rating prediction, and hence whether it is going to recommend or not based on the rating prediction. 4 or more than 4 means it will recommend, otherwise it won't recommend. That is the threshold I fix. Suppose if you want to make 3 also fine, based on the development of your product, maybe you can fix 3 also fine. 3 or more than 3 means we can recommend. In that case, item 5 is recommended to Divik. So that's why, so in the product we have to fix the threshold value, whether you want 3, whether you want 4. So it depends on the application. Now we have a small quiz for participants. So we have 3 movies like movie 1, movie 3, movie 4. So these ratings are not available. That means we have to find rating prediction, and we have to decide which movies are going to recommend. So now I will give similarity between Vishnu to other users. Based on that, we can decide. So we have 4 users and 5 movies, and this matrix values are missing. Vishnu to movie 1 rating is not available. That means he did not watch that movie. And Vishnu to movie, he did not watch that movie. He did not watch that movie 4 also. Now I will show right side similarity between Vishnu to Divik 32.3, that means 32%, and Vishnu to Ramesh 73% or 0.73, and Vishnu to Somu 21%. Now tell me what is the rating prediction, and hence which movies we are going to recommend to Vishnu. Ramesh. So I given similarity between Vishnu to Ramesh, Vishnu to Divik, Vishnu to Somu. Now we have to find rating prediction followed by which movies we are going to recommend to Vishnu.
Ramesh. Vishnu to Ramesh.
Correct. So Vishnu to Ramesh, because highest similarity is there 70%. Now what is the rating prediction? Whatever rating given by Ramesh to movie 1, movie 3, movie 4, same thing, copy paste here. So 5, that is because there is a huge similarity 1, 4. Now we have ratings, we predicted 5, 1, 5, 1, 4. Now which movies we are going to recommend? Rating prediction done. Why means Vishnu Ramesh having highest similarity 73% when compared to rest of the users. So therefore rating prediction, whatever rating given by Ramesh, that same copy paste here. Now according to our system, recommendation system, minimum rating should be 4 for recommendation. So whether movie 3 is going to recommend to Vishnu?
No.
So because rating is very poor, hence maybe this movie 100% not going to recommend to Vishnu. Movie 1 going to recommend, movie 3, 4 going to recommend. That means rating is 5. So that means obviously both are having similarity. Maybe he also liked that movie. That's why movie 1 is recommend to Vishnu, and the movie 4 rating also 4. So this also is going to recommend to Vishnu. Whether Vishnu is going to watch or not, that is left to Vishnu. But the recommendation system objective is to recommend movie 1 and movie 4 to Vishnu. So based on his interest, he will watch or not, that is left to him. So that is the objective of recommendation. I think it's clear recommendation. The objective of recommendation system is to predict the rating followed by recommendation. If the minimum rating is 4, it will recommend, otherwise it won't recommend according to the my model. Maybe we can make 3 also fine, depends on your application. So final conclusion, movie 1 and movie 4 going to recommend to Vishnu. So this is the conclusion for the quiz. Now coming to the healthcare, I think it's clear movie recommendation or product recommendation. Now the question is how it will help to the healthcare industry also. So because of less time I'm moving, because still so many things are there. So I think movie recommendation, product recommendation is clear because we are looking for similarity between users. Based on high similarity, we are recommending, we are predicting a rating, hence followed by recommendation. Now we will see how the recommendation comes to the healthcare industry. So is it required in the healthcare industry? If so, what is going to happen in the healthcare industry by using this recommendation system? What we done for movies or what we done for the product? So that we will see example. So in recommendation system for healthcare, one is food recommendation. So for example, I have a cancer. So based on my disease, the automatically I'll get recommendation. You have to take morning two idli, maybe afternoon this type of food, maybe evening snacks this type of snacks, maybe night we have to take this type of food like that. So that means depends on the disease, automatically you will get recommendation. So that is called food recommendation. That is one type of recommendation in the healthcare industry. And drug recommendation. Drugs means suppose I am looking for a fever tablet. If I type fever, then I will get recommendation of the tablets related to fever. How it possible? What is happening exactly? Or maybe I'm looking for the tablets or maybe drugs related to COVID-19. So what type of drugs required? It will recommend automatically. So this type of recommendation also comes to the picture and healthcare. I will show clearly. And physical activity recommendation. Suppose most of the patients having this lagging of physical activity, like morning walk or evening walk or maybe any type of exercise. So what type of exercise you have to do as a sugar patients, or what type of exercise or physical activity you have to do as a cancer patient. So this type of recommendations will get automatically. You have to morning wake up 5 o'clock, half an hour we have to do jogging, and half an hour we have to do running. Like this type of activities will get recommendation. And healthcare professional recommendation, like I have a cancer, let us assume. So it depends on my cancer, I will get a specialist maybe near to my area. Maybe one doctor is available, cancer specialist, I will get automatically recommendation. Or maybe I have fever, so based on the fever, so I will get recommendation of the doctor specialist for fever. So this type of recommendations will get in the healthcare profession, I mean healthcare industry. So now I will show case studies so that we can understand exactly what is, how it possible for recommendation. So this is the data set which I got from one of the Springer journal, their recommendation for healthcare industry. So that data set I have considered as it is. It's very quite interesting, and that this paper is published last year only. Sorry. Now this is a data set. We have 4 patients. You can see patient 1, patient 2, patient 4, and we have attributes. So age, these are all symptoms: insulin level, glucose level, BMI, that is called body mass index. Even I don't know initially what is BMI. Then I searched in Google because these are all medical terms. We are all new to these terms. So BMI means body mass index, BP means blood pressure, and thickness means fat level in the body. So if we take patient 1, all the attributes values are given. Patient 2, patient 3, patient 4. One active patient, let us assume Tom. So that is the given in the publication also. Tom is name of the active patient. So he is having age is 25 and insulin level is 25.4 and glucose level and BMI level and BP level and thickness. Thickness means here Krebs thickness means, so meaning is fat level in the body. Now the question is, so what type of prescription is recommended to the active patients? Already we have 4 patients. Now I have to recommend one prescription to the patient. So based on the active, I mean old patients, how it possible? Here what we are going to do is we are looking for similarity between active patient with other patients. Now we can see here. So the similarity between Tom and patient. Just now we discussed the similarity between 2 users and how movies are recommending or how the products are recommending. In similar way for healthcare also, the similarity between Tom and patient 1 is 86%. So, and the similarity between Tom and patient 2 is 51%. The similarity between Tom and patient 3 is 49%. The similarity between Tom and patient 4 is 4%. Now we can see here, when compared to all the similarities, Tom and patient 1 having high similarity, that means 86% similarity. So Tom is active patient. Today only he visited, maybe he is trying for some prescription. Patient 1, patient 2, all these are already existing patients. Now we can see how similar means age is almost close, insulin level is almost close, and BMI also almost close, BP level almost close, and fat level also almost close. So because of that reason, 86% similarity is there. Now what is the conclusion? So the calculation shows that patient 1 is more similar to Tom. Now the conclusion is whatever drugs prescribed for the patient 1, same thing will recommend to Tom also. That is the advantage. Without consulting any doctor or without taking appointment of any doctor followed by consulting, I got directly what drugs I have to take for my symptoms. So like based on insulin level, glucose, etc. So that means, so let us assume patient 1 having some prescription suggested by the doctor, like tablets, etc. Same thing we are going to recommend to Tom also. So that is called healthcare application, how the drugs recommendation or maybe prescription recommendation to the active patient. So I think it's clear. Here we are looking for similarity between the active patient with other patients. So here you can see the conclusion. So this is the patient one prescription, RX. RX means prescription in the medical terminology. So this is a patient one prescription given by doctor. Because of patient one and active patient Tom having both similarity symptoms, automatically this will recommend to Tom also. Without consulting doctor, he got the prescription. Now we will visit any pharmacy or medical shop. He will get all the tablets, whatever prescription is available. So we have some prescription given by the doctor or recommendation, he will get automatically. So this is the way the healthcare application plays a vital role for recommendation. So that's why this is called a drug recommendation in the healthcare industry by using machine learning model. I think it's clear. So here name of the patient is Tom, here name of the patient is patient one. So whatever prescription is given to patient one, same thing will recommend to the active patient, that means new patient Tom also. He is not visited any doctor, but he will get automatically. Why means maybe in the website he entered all the details, immediately he got this prescription. Maybe he has to pay a minimum amount. So based on that, he will go for further step. I think it's clear. This is one of the healthcare application. Now here we have health status prediction also we have. So here what we have to do is, so we have to find the similarity between active patient to other patient. Maria is an active patient. We have to find similarity between other patient. So like Maria and kidney damage similarity 82%. Maria hearing impairment 89%. Heart disease. So this is health status prediction. Maybe short time we are going to get kidney damage, or maybe within short time we are going to get heart attack. Like that we can find the health status. Based on that I can go for immediate precaution. So that is the recommendation here comes to the picture. So here we have to find the similarity between Maria to kidney damage possibility and Maria to hearing impairment possibility and Maria to heart disease possibility. Out of that we can see here 89% similarity, that means a possibility for hearing impairment when compared to the kidney damage and heart disease. So therefore there is a problem with hearing issue in the future, so hence he has to take a proper action. So that is called health status prediction. In health status prediction, so based on the symptoms, so it will compare with other symptoms. Based on that it will recommend there is a possibility for heart disease, there is a possibility for kidney damage. So based on that recommendation, the patient will take care immediately action. Maybe he will go for diagnosis, or he will go for further steps, so that he will try to minimize that heart attack, or maybe hearing impairment, or maybe kidney damage. So this is also one type of recommendation. Maybe same thing, tablets also, drugs also it will recommend. Suppose I'm looking for maybe what we can call it as a fever, then based on the highest rating pharmaceutical company tablet, it will recommend automatically. We have different types of pharmaceutical companies for manufacturing or producing the fever tablet, but we have to see the rating. The recommendation system will see the ratings of the customers. Based on that it will recommend automatically tablets recommending by S. So S indicates here, so Sun Pharmaceutical Industry Limited. So whatever tablets produced by Sun Pharmaceutical Industry Limited, it will recommend automatically to the customers. So that is also one type of application of recommendation system by using machine learning models. We can call it as a drugs recommendation. So similarly here we have a doctor recommendation also. So if we type the symptom, you will get automatically recommendation of the doctor. Suppose if I type, let us assume fever, I have a fever, let us assume, automatically I will get doctor near to my area. So that is called doctor recommendation. Or if I type, let us assume COVID-19, automatically I will get a doctor recommendation of COVID-19. The doctor who is a specialist about COVID-19, I will get recommendation. So this is also one type of recommendation engine in the healthcare. I think some message I'm getting. Yeah. So someone asked question. Sunday AJGB, whatever it may be named. Please examples of popularity, content, and I think already I gave us a popularity means based on the most trending videos, it will recommend automatically. Content based, I explained clearly, based on the past activity of the user. Collaborative means it will look for similarity between users. I think I gave so many examples also. I think now understood, sir. Because based on the comment, I'm reading the comments. I think that is the only one question here. So that so many we all discussed collaborative filtering examples only. Based on the rating, it will recommend drugs, it will recommend products. So whenever there is a similarity between users, it will recommend. Content based means based on the past activity of the user. I gave example. I used to purchase only Fair and Lovely cream, or maybe I used to purchase only Samsung mobile. So whenever Samsung mobile model came to the market, then automatically I'll get recommendation. That is called content based algorithm. So that is the end of recommendation. Now I will move to the cyber security case studies, how machine learning or data science comes to the cyber security. So in cyber security, so we know cyber, whatever crimes happening through computer or maybe network, that is called cyber crime. There are so many cyber crimes. We have hacking and computer viruses injecting, or maybe cyber terrorism like spam mail, ham mail, or maybe phishing. So many things are happening because of the cyber crimes. And what is the requirement of cyber security means cyber is nothing but computer system and program, all those things comes to the cyber. So we can see cyber cap, all those things. Computer is a cyber, program also cyber, network also cyber, data also cyber. So to protect these things like networks, program, all those things, we require some security mechanism. So for that, cyber security comes to the picture. We have different security mechanisms. By using that, we can protect the cyber, that is called data, network, all those things. So that's why cyber security is nothing but set of technologies which will protect the data, program, computers, etc. So that we can minimize the cyber attacks. So otherwise, every day we are being influenced with cyber attacks, maybe hacking or maybe some type of virus injecting to our network, etc. So that's why to minimize all those things or to reduce all these risk of cyber attacks, we have to go for cyber security. That is a basic simple definition. So is the hacker is trying to access data from the organization. So because of cyber security, now we try to minimize. If there is no cyber security tools, then directly will access all the data from the organization. So that's why cyber security plays a very, very vital role for all the organizations nowadays. Now, cybersecurity uses data science, artificial intelligence because of more data, and we have to do some clean data, and we have to do some pre-processing. So many things we have to do. That's why. So, artificial intelligence, machine learning, data science comes to the cybersecurity. And the data set looks like this. That is supervised learning algorithm we are going to apply. So, just I will move this. Still, we have 10 minutes left. And here what we have to do is we are going to apply Naive-based classifier for classification of the data is good or bad. So based on the highest probability, we are going to decide whatever data we received, it's a good data or maybe a bad data, or we can call it as a malicious data. Maybe one more thing is so email spam detection. I already said, so we used to receive everyday mails. So whenever some receive mail, some mails will go to spam folder, some mails will go to the inbox. So or maybe ham mail, we can call it as a not spam. So this is also one type of service fraud. So because some of the attackers will send some mail, and if you click that link, maybe it will take data from your system, or it will take your details of credit card, etc. Based on that, they will go for further step. So because of that reason, how to classify the mail is spam or not spam? So for that, we have to apply this machine learning. So this is the data set looks like this. So ham is not spam, and the not spam mail, and spam is, we know that is a mail having some type of attacks. So for example, if we take here one example here, so spam mails in general having winner, maybe best cash prize, or maybe $1 billion winner, like that. You can see here winner, and you won the cash prize of $900, and please call to some number. Like this type of mails we used to receive. These are all spam mails. So maybe possibility for attacking through spam mails. That's why our machine learning models, what it will do, automatically it will classify the mail is spam or not spam. So this is the data set available in the Kaggle, or you can go for UCI machine learning repository. There you can download this data set. This I already shown. This is my spam mail what I received. Here you can see Somasekar, you want bumper gift, like that. So this is spam mail. If I'm trying to click this one, automatically possibility to ask for my credit card details, hence possibility for cybercrime. So this is the mail in general. Let us assume I have received mails 5 so far, and this data is available. There we have words like this, keywords or buzzwords: free, weather, lottery. Lottery means understood, spam mail, data, promotion, signs. So 0 indicates lottery is not in the, lottery word is not in the mail. So 5 means 9 frequency, 5 frequency of lottery word. You can observe that wherever spam label means output, these are spam mails. Wherever spam is there, you can see here lottery word is repeated 7 times, 9 times, 5 times, or similarly free. So free is repeated 3 times. Maybe today you can visit our hotel and lunch free, like that you will get message. If you click, then they will ask so many other details. So this type of keywords you can find in the spam mails. Suppose new mail received, there we have free 7 words repeated, lottery repeated 6 times, promotion repeated 8 times. Now I have to predict whether the mail is spam or not spam. So machine learning model will predict automatically whether the mail is spam or not spam. So here you can see what we have to do is we have to find the probability of for spam for the given futures, whatever futures here, like these are nothing but futures x1, x2, xn. So based on that we have to do it. So we have to find the probability of spam. Let us assume probability of spam is here 0.7, probability of not spam is 0.1. Obviously 0.7 is more than 0.1, hence we can classify the given mail is a spam mail. So this is the simple way. By using Bayesian classifier we can classify the spam probability is more than not spam probability based on the mail what we received. There we have free is repeated 7 times, so data, promotion is repeated 8 times, lottery word is repeated 6 times. By observation only we can say it is a spam mail, but by using machine learning model that is called Bayesian classifier, so 0.7 probability we got spam for given in for futures and 0.1 probability for the given futures. So 0.7 is more than 0.1, hence the mail is classified as a spam. So this is the final classification for a given mail is spam or ham. So maybe if you are looking for more research point of view, you can go through this publication, proposed efficient algorithm to filter spam using machine learning. This is published in Elsevier journal. So we know Elsevier publications are very standard. So you can go through this publication, because spam concept only we can take 2-3 hours, that much lengthy topic. Just I gave basic idea. So based on the probability, if the probability is high for spam, then the mail is classified spam. Otherwise the mail is classified as a not spam. Of course, here NLP also comes to the picture if you want to go for more accurately. And similarly, intuition detection system also we can use by using a classifier that like Bayesian classifier. Intuition is nothing but unauthorized access. So whenever if I take our network, we have a network. So data is received in, through packets. So whenever if there is an unauthorized access, maybe someone trying to attack our network, maybe through a virus or maybe through any other type of attack, then how to detect this one? So that is called intuition detection system. Once the intuition detection system comes to the picture, it will detect the intuitions and it will give alarm to the administrator, so that we'll go for further step. Otherwise they will attack our system or maybe organization server, etc. So then it is a big issue. Because of that reason, machine learning models comes to the picture. Based on that, it will predict the intuitions, hence it will give alarm to the administrator. So here this is the basic idea. So the data set looks like this. We have so many attributes, and we have to classify whenever any data received, whether the data is good data or maybe bad data. So like this. So this is the simple example I'm taking, synthetic data. We have a data futures x1, x2, x6, and labels are available. Normal data, Neptune means one type of attack that is related to the web servers. And whenever new data is received, let us assume x1, x2, x6, I have to classify whether the mail is, whether the data is normal data or malicious data. That I have to classify. So that is the intuition detection system. Here what we have to do is, we have to apply, one second, tell me. One second, don't mind. Where, madam?
Varun Devi, he went for sports, sir. His bone got dislocated.
Okay.
So they want to ask help from students, sir. So we took permission from principal.
Okay. A civil student, madam?
Civil
okay. If you want, we can visit classes.
Visit classes.
Okay, fine. Even later, you can visit faculty also, madam. We'll try to help. No issue. Yeah, no issue. Yeah, sorry. Yeah. So here, whenever if I receive any new data through our network, we have to classify whether the data is malicious data or good data, good or bad, or maybe any type of attack. So for that also we have to apply machine learning models. Based on that, we have to find highest probability. So this explanation I'm not giving directly, I'm giving answer. So we have to use Bayesian classifier. Based on that, whichever maximum probability, here 18 by 2430 is the maximum probability, which corresponding to attack that is called Neptune. Hence, the data what we received, that is one type of attack. So immediately, so administrator will take care immediately. So someone is attacking our server or maybe organization systems. So immediately the administrator will go for further step. So this is called intrusion detection system. So based on that, we can detect whether the data is good or bad data. So their machine learning comes to the picture. So by 2025, 80% of the companies are going to use AI or machine learning models for this type of cyber security applications, according to the Capgemini report. Recently, I read one of the article. There they specified most of the companies, they are going to use AI or ML models to do this type of cyber security applications by using ML models. And even regression models also we can apply for weather forecasting. For example, we have so many regression lines. So regression lines basic idea is it will establish the relation between dependent variable and independent variable. For example, if you take x, y, so let us assume this is day, I'm assuming, let us assume x, and this is number of COVID cases. So simple example. So this is number of COVID-19 cases. So 1, 2, 3, 3 days, COVID cases are 5, 6, 7. Now fourth day, I want to find how many number of COVID cases. So this is called regression model. We have to establish the relation between dependent variable and independent variable. Let us assume linear regression, y equal to a plus bx. So b is nothing but slope, a is nothing but y-intercept. So we have to establish the relation between x and y. X is independent variable, y is dependent. Y means the value of y depends on value of x. That's why dependent variable. Once if we establish the relation, let us assume the regression model looks like this. So 2 plus 3x, let us assume. So now if we substitute x value, we can predict the value of y corresponding to x. So that is the basic idea of regression. Regression model makes relation between two variables or maybe more than two variables, one independent variable, one dependent, or one dependent variable, more than one independent variable. But the dependent variable is always one, that is called response variable, and predictors are nothing but independent variables. So based on that, we can establish the relation. Hence, we can find the value of y corresponding to x value. So this is called a regression model. Based on that, I will show one of the case study. So coronavirus disease, this is the website. We can find coronavirus source data, our world data. There we can find everyday information of COVID-19 cases across the world. So you can see here, so country is available and some places, and here we have number of COVID cases each day, every day up to yesterday you can find a number of COVID deaths, everything is available. So based on that, we can make a model. Hence we can predict number of COVID cases tomorrow or number of COVID deaths tomorrow. So this data you can download from our world data. There you can download this one and you can apply for your research also. So this is one small example, predictive modeling of COVID-19 confirmed cases in Nigeria. These authors use a linear regression model. By using that, they calculated a number of COVID cases. So this is a simple linear regression model they used, y equal to a plus bx. So based on that, they evaluated the number of COVID cases. So I will show the results here. You can see here, according to the linear model, confirmed cases 232, and they predicted by using linear regression 231 cases. Both are almost same. 238 cases, they predicted 249 cases, 240 cases, 343, 340 cases, almost very close. So by using this machine learning model, so they predicted number of COVID cases. Based on that, they can go for further action. If the COVID cases tomorrow, let us assume 1 lakh in a state, then immediately we have to improve the hospital beds and our number of doctors, everything we have to take proper action. Otherwise, there is a possibility for huge number of deaths. So this type of applications, we can go for machine learning, predictive modeling, that is called regression models. Hence we can predict the future value. Not only COVID cases, maybe weather forecasting or maybe rainfall, etc. also we can predict by using the machine learning models, and which comes under data science. And even one of the Indian author published a paper, linear regression analysis to predict the number of deaths in India. Previous paper is number of COVID cases, in this case number of deaths. So based on linear regression, we can predict how many number of deaths possible. So this is one of the case study by using which we can predict the number of cases or number of deaths. So now if anyone interesting to do, I explained so many concepts like healthcare application, cyber security application, recommendation system, and predictive analytics like regression analysis, case studies, etc. And if you are looking for still more in-depth concepts, you can go for these other resources, recommendation system with Python, machine learning for cyber security, because I explained very short within one and a half hour. But for me, for preparing recommendation system may take around more than 40-50 hours, or maybe cyber security 30-40 hours. So it's not that much easy to prepare. That's why you have to go through these textbooks in depth. Then you can understand exactly what is happening here by using data science or machine learning models. So these textbooks are available in online also. You can download free of cost, and very good textbooks, and you can find the code also, Python code. And practical statistics for data scientists is very good for statistics and probability concepts, because without mathematics, probability, statistics, nothing to do with these machine learning models. You can observe all the models, we have a lot of mathematics is there. So if you are weak in mathematics, also try to go through these textbooks and learn mathematics, then you can go for understanding the algorithm, so that you will become a good data scientist or maybe good in data science. These are also available in the Google, you can download. So that was my talk. If you have any queries, I'm happy to answer. So 2 more minutes left. So I'm happy to answer, because so many things we covered within a short span of time. But still, if you have any queries, I'm happy to answer, or if any suggestions. Yeah. Yeah. So Pooja Jaiswal, can you conclude? Can you please repeat the movie conclusion? So movie conclusion, I will show once again. You can understand. 1 second, madam. I will show according to your. Just a second. Yeah. Yeah. Here I will show. You can see the madam movie conclusion here. Just I'm showing Pooja for participants Pooja. Yeah. So here what we done is, so we done rating prediction. So Vishnu and Ramesh having more similarity. Whatever rating given by Ramesh, we are assigning to movie 1. That is the prediction what we are doing. Whatever rating assigned by Ramesh to movie 3, we are copy paste. Whatever rating given Ramesh to movie 4, we are copy pasted here. Now you can see 1 rating is very poor. We are not going to recommend movie 3 to Vishnu. We are recommending movie 1 because of 5 rating. Movie 4 also we are recommending 4 rating. Minimum rating should be 4 for recommendation. That's why movie 1 and movie 4 are recommending to the customer Vishnu, that is user Vishnu. Whether he is going to watch or not, that is another issue. But the recommendation system will recommend only these 2 movies. From the 3 movies, out of 3, movie 1, movie 3, movie 4, movie 1, movie 4 only will recommend to Vishnu because of good rating prediction. I think you understood the concept. So, yeah, how to choose Apasami? Yeah. How to choose best ML or DL model for medical image analysis? Medical image analysis, we have to go for deep learning, sir. So convolution neural networks is useful for image related data. Or if you want to go for what we can call it as a structured data, we have to go for. Thank you, madam. Thank you. Yeah, thank you, man. Thank you, Pooja, madam. So for structured data, you can go for machine learning models, sir. For unstructured data like image kind of things, we have to go for deep learning, that is called convolution neural networks, sir. We can apply. We have to take input as a image, and each pixel value is nothing but 1 neuron. After that, we have to do processing layer. Then finally, you will get output layer. There it will predict whether the image having COVID-19 or not, whether cancer or not. Like that, we can go for diagnosis, sir. I think it's clear. Srinivas Murthy, Tirupati. Yeah. So I'm also from Tirupati, sir. Srinivas, sir.
That was an outstanding session, sir. Great presentation with a lot of specific and helpful information. Thank you.
Still any queries?
Any other doubts?